Hello, I'm going to present the work my team and I have been developing with an effluent of olive oil called olive meal wastewaters and its antimicrobial activity. The Mediterranean area is one of the world's largest producers of olive oil, producing around 95% of the worldwide olive production and consequently of the wastewaters produced during this process, olive meal wastewaters or OMWW, which are becoming an increasing environmental problem due to their toxicity. The quantity of olive meal wastewaters that is generated and consequently the environmental impact depends on the method of olive oil extraction that was used. The traditional cold press method typically generates about 50% of olive meal wastewater relative to the initial weight of the olives, while the continuous centrifugation process generates 80 to 110% of olive meal wastewaters due to the permanent washing of the olive paste with warm water prior to oil separation from the paste. Phenolic compounds can act as natural pesticides and provide protection against ultraviolet radiation, and it's generally accepted the existence of a linear relation between the total phenolic content and the antioxidant properties of a particular vegetable species, with olive meal wastewaters being a good source of phenolic antioxidants. For this work, 2 olive meal wastewaters are obtained from a traditional discontinuous press and a 3-phase centrifugal continuous system olive mill. Given their high density, both samples were first passed through a coffee filter to remove the majority of particles that were in suspension and then filtrated through vacuum filtration. Additionally, subsamples of the 4 samples was freeze-dry submitted to lyophilization. I wanted it also to be noticed that I am a master's student with a mechanical engineering background with no experience in this field of microbiology. So I had the help of a pharmaceutical PhD student to perform this work. The olive meal wastewaters were analyzed for their total phenolic compounds content, antioxidant activity, and also for its antimicrobial properties. In the results, the left table presents the results obtained from the determination of the total phenols of the olive meal wastewaters extracts that show slightly higher values for the olive meals obtained by the traditional method when compared with the continuous one. The step of vacuum filtering does not seem to have a great impact on phenolic compounds concentration, although some loss was observed in the samples obtained from a traditional system. The table on the right shows the obtained results by the application of the DPPH radical uptake assay, where all the samples demonstrated free radicals uptake activity superior in both filtered and non-filtered traditional olive meal wastewaters, which agrees with the higher phenolic content observed on these extracts, demonstrating that the antioxidant capacity is dependent on the content of phenolic compounds present in the extracts of the olive meal wastewaters. The antimicrobial activity analysis was performed with the lyophilized samples and also directly with the wastewaters. For the lyophilized olive meal wastewater, the obtained powder was dissolved in the Muller-Intern broth to obtain a solution of known concentration that was then serially diluted. The figures on the left are an example of the microplates results obtained after incubating with INT. The wells for which no growth was evidenced by turbidity and interdiction were plated to agar plates to determine the MBC and estimate the bactericidal capacity of the lyophilized samples as shown on the right photos. Here we can see the obtained results for the antimicrobial activity on the extracts on the left and the direct samples on the right. And in general, better results were obtained when testing the olive meal wastewater directly when compared with the lyophilized samples, particularly for the filtered samples obtained by the traditional method that showed inhibitory activity against all 8 tested microorganisms. Nevertheless, the olive meal wastewater obtained by the continuous method also evidenced good results against S. aureus, E. fecalis, and P. mirabilis. To conclude, regarding the phenolic content, slightly differences were found between the traditional discontinuous press and the three-phase centrifugal olive oil extraction process, with the first presenting slightly higher values. These samples were also the ones showing higher antioxidant potential, as the antimicrobial tests revealed that the olive meal wastewaters has the capacity of inhibiting bacterial growth, especially against Klebsiella pneumoniae, Staphylococcus aureus, Proteus mirabilis, and Enterococcus fecalis. The results also demonstrated that olive meal wastewaters have antibacterial activity, even when they are used directly in the liquid form and diluted to 50% or more, therefore suggesting that this residue can be a natural microorganism inhibitory agent and can potentially be exploited for different purposes based on this activity.